So Bismillah ar-Rahman ar-Rahim. We come to the last activity of this chapter, and in this activity or in this topic we talk about IPv6 subnetting. IPv6 subnetting is quite similar to IPv4 subnetting. The same reason, same everything. So network isolation, reducing broadcast domains, and but there are some minor differences that you need to pay attention to when we talk about subnetting for IPv6. The first thing is that here the address structure is based on hex bits, which are based on hexadecimal digits. So each hex bit is actually 16-bit, not 8 bits. 16 bits, and these 16 bits are organized as hexadecimal digits. So this is the first thing, and this should be already known by everyone. But the other difference, which is much more important, is to pay attention to the fact that for IPv6, we do not have broadcast addresses as part of subnetting. Which means in general that if the interface ID has n bits, how many usable interface addresses can I have? 2 to the power n minus 1, not minus 2. Okay? Because there is no broadcast. IPv6, of course, uses all node multicast instead of broadcast. And that has a separate addresses altogether. We talked about this. So for multicast, we have assigned multicast, solicited multicast, and all of this. And these use different range of addresses for IPv6. But here, there's no broadcast. So these are the two major differences between subnetting for v4 and v6. So here, I'm asking you to subnet a network prefix which is 48 bits, okay, which is, of course, 3 hex bits. 3 times 16 is 48, which has this prefix. Subnet that using a subnet ID, which is composed of 20 bits. 20 bits, which means 1 hex bit and 1 hexadecimal digit, just to make it a little bit interesting. Okay? And to write the first interface address and the last valid interface address for each subnet. Of course, how many subnets do we have here? How many subnets do we have? Huh? How many subnets do we have? 2 to the power? لا يعني هنا the subnetting is based on fixed number of bits. 2 to the power 20, which is the number of bits assigned for the subnet part. Okay, 2 to the power 20. That's of course huge number. So definitely, I'm not asking you to write them all down. Okay, but we need to write some of these subnets together. So write the subnet address, the subnetwork address, the first interface address and the last interface address for the first few subnets. And I want you all to write it down. Do not rely on the fact that you calculate this in your head. It doesn't work. You have to write it down. Okay? So the final subnet ID is when you put the subnet ID part all Fs. Yani 5 hexadecimal digits, all Fs. Right? So the first 3 hex bits are the same. Then the subnet ID part, which will be F, which is this 4, colon, F, which corresponds to this one, right? And then the subnet ID part. The interface ID part, which is the blue. For the network address or the subnetwork address, the interface ID part is all zeros, right? So we have to put the 3 zeros on the right-hand side, because these are not leading zeros that we can omit. And then colon /68. This is the last subnet. Okay? Type. The first valid interface address is easy. It's just to take this part as is and put colon 1, which is to take the interface ID and put 1. Increment 1 to it. Okay? And then the last valid interface address is to put the same 3 hex digits and then F, colon F. This is the subnet ID. And then the interface ID is also all Fs, which is F, colon F, colon F, colon F. All Fs. Okay? So for each of these subnets, we have 2 to the power 60 addresses minus 1. And this one is only the A for the subnetwork address. So subnetting is easy. It's only to take the subnet ID part, incremented by 1 every time. That's it. Okay? Any questions? So, of course, this is the end of chapter 9, and now I will take you back to chapter 7. In the protocol stack, we actually go 1 level up. So here we finish, by chapter 9, we finish everything related to network layer. Whether addressing, subnetting, routing, everything. Okay? And now we go 1 step up and go to the transport layer. So the first thing in the transport layer is to talk about the role of the transport layer. And just to put the transport layer in perspective based on what we have studied so far, we talked about data link layer, which is responsible for low-level communication between 2 network devices. Low-level communication between 2 network devices. A switch and a router, router and a router, router and a switch, and so on. And it facilitates the communication within 1 LAN only. Okay? Network layer routes packet from 1 network to another. Okay? To provide end-to-end communication between 2 hosts. The host is identified by IP address. Okay? So that's what we talked about so far. The transport layer is responsible for application endpoint communication. So if we know that we have 1 host, H1 and H2 and H3, each of these hosts are running multiple applications. By application, I mean any software that runs on this host. Even if you have a browser, each tab in the browser is a separate application endpoint. We call it endpoint as a generic term to refer to any application, whether it's client, server, peer-to-peer, telnet, FTP, HTTP, any application endpoint. Okay? So this host is running multiple of these application endpoint. This application, or this host, sorry, is also running multiple applications. And this host is also running multiple applications. So for example, this application could be HTTP client, which is one of the tabs on the browser. This one, telnet. This one, FTP. This one, YouTube, مثلا, which uses مثلا VoIP, voice over IP, or video over IPTV. Okay? So here, this one is, for example, this one again is DHCP. DHCP is a client which runs and connects on a server to get dynamic IP address configuration. So all of these are applications running on this host. Here there is HTTP application, there is here DHCP application, and here there are some other applications. So transport layer protocol facilitates the communication between 2 application endpoints, okay, running on different hosts in general. So this application here communicates with one application on host 2, and this application on host 1 communicates with one application on host 3. So each of these, we call it conversation, or some communication between two application endpoints. It's like two people communicating together. So this goes back to the basics that we talked about in the very first lecture. The concept of a protocol in general, that two applications, when they talk together, they have to use the same language. So I cannot, for example, connect Telnet here with DHCP. I cannot do that. Right? So the two applications have to use the same language. And the transport layer protocol facilitates this conversation. Yani it creates the end-to-end conversation between these two application endpoints. This is the basic function of the transport layer, of any transport layer protocol. So with that, there are some basic characteristics that the transport layer provides to facilitate this communication between two application endpoints. Basic characteristics. Similar to the fact that when we talked about network layer, we said routing, we said fragmentation, and all of this, right? So here there are also some basic characteristics. The first one is the concept of tracking these conversations. So we need some way of separating this conversation from this conversation. And the way to do that is by using the sockets. We all dealt with the socket at one point, right? So each socket represents conversation between application endpoint and another application endpoint on another server or another host. So tracking conversation is to separate these conversations from each other by using different buffer or different socket for each of these conversations. So this is tracking conversations. Number two, segmentation and reassembly, of course. Segmentation, we talked about this in the very first lecture as well. We said that for each of these applications, the application gives me the information as stream of information coming from a browser or from Telnet or from FTP client and so on. What the transport layer does is that it actually breaks down this information into what we call a segments. So we have to use segmentation. And we call the segment as the protocol data unit in the transport layer. So transport layer has to do a segmentation. Segmentation also facilitates the fact that different segments coming from different applications or different hosts, they can share the same network medium through what we call a multiplexing. So there is also the concept of multiplexing. So segmentation, in fact, facilitates multiplexing. Why? Because when I break down the large piece of information from the application into smaller segments, I can interleave and mix these segments from different applications, rather than if I have very large information, one application or one user sends this large information on the network medium, what will happen is that the network medium will be consumed forever, will be consumed for a large amount of time, preventing or stopping any other user from using that network medium, which is not efficient. So segmentation, in fact, facilitates the efficient use of the network medium through multiplexing or interleaving segments from multiple applications, possibly running on different hosts. ماشي? So segmentation facilitates the multiplexing or mixing or the interleaving of these segments from multiple applications. And last but not least, I have to identify applications. بمعنى since I have segments and I mix these segments together, on the receiver endpoint, on the receiver application endpoint, I will receive stream of segments. I will receive consecutive segments, right? So we can draw this. So if we have here, this is the transport layer, this is the lower layer, and here we have the application layer. Okay? So the transport layer will then receive stream of segments which are possibly coming from different applications, from different application endpoints. And here I have multiple applications running in the application layer. So I need to have a way of saying this segment goes here, this segment goes here, this segment goes here. It's exactly similar to what we have done from the data link layer to the network layer when we said that we will use the type field to refer to the protocol in the upper layer. In the network layer, we use the protocol field to point to the protocol in the transport layer, whether it's TCP or UDP or ICMP or something like that, right? Also here, I need to identify the application endpoint in the application layer. And for that, we use the concept of port number. In the transport layer, one of the fields is the port number. One of the fields is, which is very important, this is the most important thing in the transport layer because it actually identifies which application that this segment should go to in the application layer. Okay? This port number not only points to the protocol in the application layer, but it points to an actual application endpoint. يعني بمعنى your browser runs multiple tabs, right? So this is one tab, this is another tab, this is the third tab, fourth tab, and so on. All of them use which protocol? Which protocol is used by the web browser? HTTP. All of them use HTTP. Okay? The port number will not refer to HTTP, لا, will refer to a specific application endpoint. So it doesn't refer to a protocol. So it's actually, the port number is used not like the protocol field in the network layer. It has some kind of addressing implicit into it. Because it refers to a specific application endpoint which uses specific protocol. So it's a mix between identifying the protocol and addressing a specific application on the application layer. That's why, what I'm saying this, because sometimes we refer to the port as pointing to a protocol in the application layer, and sometimes we refer to it as addressing from the transport layer perspective. And in that case, we have three types of addressing. We have physical address, data link layer, logical address, network layer, and we have transport layer address, which is the port number. So the port number identifies a specific application endpoint in the application layer. Okay? So that's this is how we identify the applications from a transport layer perspective. So that said, I'll give you just a few seconds to think about mapping this definition to one of these basic characteristics for the transport layer protocol. So these are the basic characteristics, and these are definitions. So I need you to map each of these definitions to a specific basic characteristic. So dividing application data into chunks. What is this? Yeah? Segmenting. Used to distinguish each web browser tab. Identifying applications. This is through a ports. Establish a connection between two end applications. Tracking conversations. Recollecting application information. Recollecting, لا. Reassembly. Telnet FTP and email clients each will have a separate port. This is a لا. يعني each application will have a separate port. بالضبط. We use port to identify applications. Okay? يعني this one is even more trickier. Each flow has separate context. Okay. Okay, so when I say the word flow means stream of packets or segments يعني which represent certain conversation between two endpoints or between two end hosts. Flow معناها ايه؟ stream of boxes يعني boxes could be segment packets. فاهم؟ لا one flow يعني each flow has separate context.
So it talks about the ports?
يعني أقصد flow معناها stream of segments, okay, going from one point to another point. ده معناها flow. يعني this flow represents a conversation between two endpoints. واضح؟ ده بمعنى كلمة flow is conversation which is represented by a stream of segments which go from one point to another. So this is a tracking conversation. Interleaving conversations. Interleaving معناها ايه؟ Segments from multiple conversations will be mixed together or combined together to be able to share one network medium. So this is a multiplex.